Hi students, in today's video we are going to discuss about raster scan systems. Okay, this PDF is from a book of Pearson. Okay, computer graphics. Let's discuss about the raster scan systems. Okay, mainly there is we have to discuss about some components, main components. Okay, first component is our CPU. Okay, then frame buffer, then video controller, then was another component is display processor. Okay, first of all, moving towards our uh, figure 17, how the image generates in our raster scan system. Okay, first of all there is system memory. Okay, and there may be a frame buffer, some memory is reserved for display generation or keep display information. Okay, or there may be no memory reserved. Here is a dedicated frame buffer memory reserved from the system memory. Okay, and then the data from the frame buffer taken to the uh, video controller, and then video control helps to displaying the image. Okay, displaying, it's mainly help to displaying the monitor. It's mainly somehow guides the electron beams, or somehow helps to guide the electron beams to in which direction to move, in horizontal or vertical, all this. Okay, in figure 16 there is no dedicated frame buffer, but in figure 17 there is a dedicated frame buffer. Okay, then let's move to our frame 19. Okay, there is a raster scan generator, then register X, register Y, then memory address. Okay, we will discuss about this. First of all, we have to discuss about the frame buffer. Okay, what is the frame buffer? Okay, a frame buffer is a dedicated memory. Okay, frame buffer is a dedicated memory that stores the uh, pixel information. Okay, like the intensity or the color, brightness, or its alpha channel, like how many, which is called opacity, means transparency of the pixel, or transparency of the image. Okay, all this. Okay, overall it's stores the pixel informations. Okay, like pixel coordinates with information. Okay, it's just imagine like the display in a x and y axis. Okay, like a 2D plane. Okay, then in a 2D plane, here is a y axis and here is x axis. Okay, and stores the pixels like coordinates in the display. Okay, and stores the coordinate information or the pixel informations. Okay, there is actually two components will be, you may be later know about this. Like there is a bitmap and a, okay, one is bitmap and another one is pixmap. Okay, another one is pixmap. Okay, what is bitmap? First of all, bitmap is a actually a practical implementation in frame buffer or inside the frame buffer. Okay, it only stores 1 bit per pixel, like a black and white display, or a pixel having a black and white display can generate black and white display. Okay, 1 bit. If one, then it's the pixel is on, like brightness or white. Okay, and if the pixel value is 0, then it is black, mean off. Okay, or off. Okay, it's mean 1 mean on. Okay, this type of information. Okay, and here is a pixmap. Okay, pixmap. What is the pixmap? Pixmap is also the inside the frame buffer. It is a conceptual model. Okay, pixmap is a conceptual model. It stores multiple bits. Okay, multiple bits. Like you can tell me that multiple bits for multiple color. Okay, multiple color. Okay, and then intensity, or there is grayscale, maybe brightness, all this. Okay, actually you can ask me that in a black and white display, in a black and white display, okay, how the gray is displayed if there is a 0 and 1 bit. Okay, it's a normal, making it clear that in black and white display, okay, there is only two color, only black and white. Maybe you have already seen in high contrast display, high contrast display. Okay, high contrast display, there is options for phones that in their accessibility about the high contrast display. uh, uh, Only two colors, one is black and another one is white. Okay, no other shades of black or white. Okay, so only two bits for our black and white. One is white and 0 is black. One is our pixel is on and 0 is our pixel is off. Okay, then you can ask that how the gray is spotted in the screen. Then I have already told that multiple bits per pixel can also store the multiple bits, maybe store the shades of black. Okay, multiple bits can store shades of blacks. Okay, shades of blacks means what do you mean by shades of blacks? Maybe this is a deep black and this is white. Okay, I can change the color. Okay, if I am adding some color here, maybe one is white and one is at the lower end. It is black, then it's gray, and then it's gray white, then more gray white, then off white, then white. Okay, all this is shades of black. Okay, for the different shades of blacks we will use multiple bits. Okay, and then there may be two frame buffers. Okay, one is a front buffer, and another one is a back buffer. Okay, one is front buffer and another one is back buffer. Okay, you can just ask then why do we need the two types of buffer? That front buffer, first, front buffer helps, uh, how the front buffer helps? A front buffer helps in current displaying image. Okay, when you are displaying the image currently, the frame buffer is, you are using the frame buffer. Okay, and the back buffer is now operating for the next image. Okay, while after the completion of after the completion of the image generation of front buffer, we have just switched that the back buffer is now the front buffer and we are using the back buffer, and the front buffer is now the back buffer and the front buffer is operating. Okay, why do we need two types of buffer like back buffer and front buffer? uh, it is clear that we are using for more suitable and more smoothly image generation. Okay, if you can ask that in only one frame buffer, why can't we do it that same time, at the same time we can uh, help in image generate or content displaying the image, and we are currently updating. uh, it's not possible in older models, but in new models this can be possible, and this is little bit complex. Okay, in single frame buffer it is complex. Okay, in it is clear that two types of frame buffer, one is front buffer and one is back buffer. Okay, front buffer, um, sorry, back buffer. Okay, front buffer helps to, or front buffer helps in displaying the image currently, while back buffer helps to updating for the next image. Okay, then let's move to the last image. There is a okay, a raster scan generator. Okay, uh, actually what is the raster scan generator? Okay, a raster scan generator is a component which actually helps in timing signal. Okay, in timing signal, what is the timing signal? Timing signal about the electrons, timing signal about the electrons. Okay, what about the electrons? The electrons generating or moving from uh, the electron gun in the CRT display. Okay, CRT display. Okay, the rasters can generate uh, to timing signal, provide timing signal, guide the electron beams, or it's move to horizontal move or vertical move. Okay, and then here is uh, two registers. One is X register and another one is Y register. Okay, two registers actually. Uh, okay, I'm clearing the display. Okay, first of all you have to look at figure 18. Okay, uh, our system is imagine, you have to imagine the display like a 2D plane, like X and Y axis. Okay, and you have to store the pixel coordinates like a 2D plane coordinates. Okay, and here is the X register and Y register. Okay, X register means it will store about the horizontal horizontal pixel address pixel informations, and Y register hold the vertical pixels. Okay, now here is some pixels. I'm drawing pixels. Okay, the X register hold the horizontal pixel information. Okay, this line information, this line information, this line information, this line. Okay, while our vertical. Okay, this in pixel information, this line information, this line information. Okay, moving downward. Okay, how this work I'm just describe. Okay, first of all X register, first this pixel information, then moving horizontal towards right, and then this information, 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 then again is set to the this information. Okay, let's assume that the X register value is 0. Okay, X is 0, X is 0, then this is incrementing. Okay, to X means the final X coordinate. Okay, then it will be reset to 0, reset to 0. Okay, then there is a convention for Y, that Y register maybe have two types of storing Y value. How? There may be a Y value is Y max. Okay, then maybe 0. Okay, if the Y value is Y max, then it will be decrementing. It is decrementing because the scan is moving towards downward. Okay, line by line and then downward. Okay, if the Y value is Y max, then it's decreasing to 0 and then reset to Y max. Okay, if the Y value is equal to 0, then it is increasing, it's increasing to Y max and then reset to 0. Okay, this is, and Y max and 0, then Y max X, what are this is the pixel coordinates. Okay, the pixel locations. Okay, it hold the information of pixel coordinates with the information. Okay, then here is the memory addresses or frame buffers. Okay, frame buffer is not any dedicated memory. Okay, there is a pixel register. It holds the intensity of the pixel. Okay, it holds the intensity of the pixel. Okay, like brightness and some more informations. Okay, then here is our new processor, the display processor is introduced. Okay, how this works, let's move. First of all we have CPU. Okay, actually generating a graphics is way difficult and consume more computational power, and our CPU is not only for our display generation, okay, or image generation. Okay, it can it have to work other operations also. Okay, So we have a dedicated display processor which actually processes the images. Okay, first of all, you have to don't confuse about video controller and display processor. A video controller helps to displaying the image. Okay, it's not processes the image. Okay, while the display processor processes the image. Okay, and then there is a dedicated display processor memory. Okay, that is, this is not the system memory. This is a display processor memory. Dedicated memory helps to process the image or generate the image. Okay, then there is a video controller. Okay, it helps to generate the image or displaying the image elements in the monitor or through the monitor. Okay, then we have to know that the display processor is only capable to handle the graphics. It helps to process the graphics, which helps in image generation or image processing. Okay, then here's a figure 21 that our like uh, displays like a this rectangle. Okay, and our how the image is generating, it only storing the these are the pixels. Okay, these pixels are divided into grids. Okay, these pixels are divided into the grids. We are just drawing a b. Okay, and how we are drawing, we are just lighting these pixels. Okay, which we are showing as b. We are just lighting these pixels. Okay, not every pixels, we are just lighting these pixels in the grid. We are not gluing these pixels. Okay, we are only gluing these pixels, the needed pixels. We have to need or we have need some pixels to draw the image or represent the image. Okay, then this is showing some example or some that in the b there these pixels are needed to glue. Okay, this is just showing. Okay, here is two types technique called run length encoding and cell encoding. Okay, cell encoding is first of all the wait, I'm telling that the run length, first of all you have to understand the run length encoding. What is the run length encoding? You have to know that let maybe this pixel and from this pixel uh, all the color are same common color. Then in run length encoding, it will store the red color continues till maybe this is our 0 pixel, this is maybe our n pixel. Okay, it will continue that red color for 0 to n pixel. Okay, 0 to n pixel red color. Okay, it is simple, very simple encoding technique. Okay, it only stores how this stores only pixel locations. Okay, 0 to n location it continues as red. Okay, then n to x continues as blue. Okay, this type of information. Okay, like if having the continuous and same in pixel information, if some pixels are continuous and having same information, then we are using a run length encoding. Okay, then here is our cell encoding. This is another encoding which is cell encoding. Actually cell encoding means it divide the image into rectangular cells or divide the screen into rectangular cells, and it stores all the cell details with cell coordinates. Cell details means which color have to glow, and uh, how much intensity, whatever the alpha information, all this. Okay, like our figure 21. Okay, it only stores this rectangular information, this rectangular information, this rectangular information. Okay, and you have to decide which rectangular to glow and store this rectangular information as nothing to glow and no brightness, nothing. Okay, but this have some color information. Okay, with the intensity and with the pixel brightness and with the pixel alpha information. Okay, all this it will store. Okay, our cell encoding is more structured or more well organized, while our run length encoding is very much simpler, Okay, this much for our raster scan systems. Okay, thank you, and we will meet in next video.